Hey, student, how are you? Welcome to our session on graphing polynomials. We're going to take a look at these two problems using the end behavior, the y-intercept, the x-intercept, and the multiplicities of each factor to determine the behavior of the graph. You could pause the video here and try them before we go through them. All right, here we go. Number one. I'm going to just zoom out here a little bit, give myself some more room. And number one, starting with the end behavior of a polynomial. The end behavior of a polynomial is determined by the leading coefficient. Our leading coefficient is 5. It is positive. And the degree, the highest exponent is 3, and that is odd. We have a positive leading coefficient and an odd degree. This means that our graph is going to go down on the left and up on the right. And we can put a little placeholder down on the left and up on the right. Next, we have our y-intercept. Our y-intercept is when x is 0. If you were to substitute 0 into this polynomial function, you'll be left with the constant value 30. So 30 is our y-intercept, the constant value. Let's graph that. Do believe these go by 20, so y-intercept at 30, right about there. All right, C, let's factor to find the x-intercepts. You could always use the rational root theorem to determine all the possible, we've got a greatest common factor. Greatest common factor. Let's factor out a 5. Always forget about the greatest common factor. It's good to review. Factoring out greatest common factor 5. All right, 5x to the third minus 20x plus 5 plus 6. Yeah, there we go. Now we can use our rational root theorem. And our possible rational roots are plus and minus the constant term, the factors of the constant term, 1, 2, 3, and 6, divided by the leading coefficient factors of 1. So these are all the possible rational roots. Let's start by substituting 1 into the function, and we'll see if we get 0. That would be the remainder that you would get if you divide out. If we substitute 1, we do not get 0. We do get 4. So x minus 1 is not a factor, and x equals positive 1 is not an x-intercept. That is the remainder theorem. Let's try negative 1. If we substitute negative 1 into our function, we do in fact get 0. So that means x plus 1 is a factor, and x equals negative 1 is an x-intercept. So we can graph negative 1 as our x-intercept. And then I'm going to use synthetic division to divide out. Just give myself some room here. You can use our x-intercept to divide out. Let's get this up here for you. There we go. Using synthetic division, we'll divide out the root negative 1. And we have our coefficients. Synthetic division will bring down the first number, multiply -1 times 1, and add. Multiply and add. Multiply. And we do get a remainder of 0 as expected. So we now have 5, the greatest common factor that we factored out earlier. And we factored out x minus 1, the root, divided by the root. So we factored out x plus 1, the factor. And then we're left with x squared minus 5x plus 6. And then we can finish factoring this quadratic. What multiplies to 6, positive 6, that also adds to -5. We get x minus 3, x minus 2, x minus 3, multiplies to positive 6, adds to -5. So then we'll set each factor equal to 0, and we do get our x-intercepts, and we can graph those. -1 we have, and then positive 2 and 3. And then the multiplicities. Each one of these factors has an exponent of 1, an odd multiplicity. So we know that the graph goes through the x-intercepts. So down on the left, we'll go through the x-intercept to our y-intercept, and then we'll go through 2, and then at some point we've got to turn around and go through 3, up on the right, down on the left. And there's a rough sketch of this polynomial. And I did graph it. Let's take a look. And there is the graph from Desmos. We've got our x-intercepts, our end behavior, and our y-intercept. All right, let's do the second example. Starting with our end behavior, determined by the leading coefficient and the degree. Since our leading coefficient is positive 1, and our degree is 4, an even degree, both ends go up. Up on the left, up on the right. Up on the left, and up on the right. Our y-intercept is the constant term, 25. If you substitute 0 in for x, you do get 25 for the y value. And we'll graph that right about there, our y-intercept at 25. And we'll factor. And you could use the rational root theorem, remainder theorem. However, I do notice that we could do x squared minus 25 and x squared minus 1. Now we can continue factoring. These are a difference of squares. And x squared minus 25 factors to x plus 5, x minus 5, x squared minus 1, x plus 1, x minus 1. So here is our factored form. We'll set each factor equal to 0 and solve. And we get -1, +1, -5, and +5. -1, 5, 1, 5. And we know at each one of these factors, since our multiplicity is odd, each one of these has a multiplicity of 1. We know that the graph goes through. So x-intercept goes through, turns around, x-intercept go through, there's our y-intercept, x-intercept go through, x-intercept go through up on both ends. And we'll take a look at our solution. I did graph it. And that concludes graphing polynomials. Thanks so much for joining our session. I'll see you next time.